would we do with 2x minus y equals 5?
We would... I just move the 2x over, then divide by -1.
5 and add y to the other side.
Or you could do that.
You could do that, and that is actually easier. I would move the y over when y is negative. So when your y is negative, move the y over to make it positive. That is better because you want a plus y, positive y. Okay? So adding that y to the other side gives me 2x equals 5 plus y. And then to get y by itself, I need to subtract 5 from both sides. So I get 2x minus 5 equals y. Now let me go ahead and graph that while I'm thinking about it. How would we graph 2x minus 5?
You go down to -5, use your intercept.
Okay, so my y-intercept is -5.
And it has a slope of 2/1.
The slope is 2. So your slope is the number in front of x. And y-intercept is the number without the x.
In all honesty, if you can't understand that way, just turn back to the form you understand. Y equals 2x minus 5. Because they're not changing the equation any, you're just simply rearranging the form that's familiar.
Okay, so to graph that, my y-intercept was -5. Click on your line here. Y-intercept is -5, so I'm going to start at -5 on the y-axis. Let's go there and click. And then with a slope of 2/1, I want to go from -5, I want to go up to -3, and then over 1. Click. Okay, I start at -5, and I go up to right 1. Now let's rearrange the other equation. What do I want to do with 5x plus y equals 2? Okay, subtract 5x from both sides. Okay, that gives me y equals -5x plus 2. Okay, so there my y-intercept is 2. My slope is -5/1. I want to start at a y-intercept of +2. So I'm gonna graph the second line right on top of this first one. So stay on your graph, just click the line again. For my second line, I start at +2. Now from there, my slope is -5. So I go down 1, 2, 3, 4, 5. That gets me to -3. And then over 1. Now I see how I landed on the same point there? That should happen on yours. The line should intersect at a good point. If your intersection is kind of like between 2 points, or it's not really looking like something good, then you probably graphed something wrong. Questions? You guys look bored, some of you are looking at me like I just did something crazy. It's actually a good review for graphs.
Okay.
Now what is my solution here? I just need to look for that intersection point. So it looks like my x is 1, and right here, my x is 1, my y is -3. So I would type my ordered pair. X is 1, y is -3. So that's just the intersection point of my key line. reverse the other direction. But it's generally better to always try to go to the right if you can. Okay, let's talk about substitution here. Number 6 is a problem where they're set up for substitution. What you want to do with substitution is you need one equation to be x equals or y equals. Now, it doesn't really matter which one you have, if you have x equals or y equals, whichever one I give you or whichever one's easier to get. Okay, what you want to do is plug that equation that is x equals or y equals into the other equation. For x or y.
How exactly does that work?
Well, let's look at it. Okay, on number 6, they give me things been cooperating pretty well. Okay, there we go. They give me x equals 4y plus 12. And then my other equation is 3x plus 5y equals 2. Now, if they tell me that x is equal to this stuff, then what I want to do is I want to replace my x in my other equation with what x is equal to.
That makes sense.
So what I want to do is I know x is equal to 4y plus 12. So I want to replace x with 4y plus 12. Okay, so instead of 3x, I have 3 times 4y plus 12. And then 5 plus 5y equals 2. Okay, so I just plugged in what x is equal to in for x in the other equation.
And then you distribute it.
Okay, now the goal of doing that is I get an equation with only y in it. So before I had x and y, now I only have y. So now I can use that to figure out what y is.
What
Okay,
if
so
you have a negative number?
a negative, what do you mean a negative number?
Well, where yours says 3x plus,
Well, that's okay. You're just going to keep it negative, and then once you distribute it, you have to replace it to that way anyway. So it's okay. It might turn out anyway.
okay.
But then once you divide it,
Alright, so you guys okay with the next step we want to distribute 3? Distribute that 3, that gives me 12y plus 3 times 12 is 36 plus 5y equals 2. So now I've just got a one variable equation. I can solve for that variable.
Can't you combine the 12y and 5y?
That's what I want to do next. 12y and 5y combined is 17y. Okay, the next thing I want to do is subtract the 36 from both sides. It gives me 17y equals negative 34. Okay, and then just divide by 17. 34 is 17 times 2, so my answer here is y equals negative 2. Okay, now I'm only halfway done because I need an x and a y. To get my x value, I want to go back to that thing that they told me, the first equation, x equals 4y plus 12. Well, now if I know what y is, I can just plug in y, and it will give me my x value. So my y is negative 2. So x would be 4 times negative 2 plus 12, which is 4. I gotta write my answers in ordered pair. My x is 4, my y is negative 2.
Now you couldn't graph this, just put those in and graph these, can you?
You can't put them in like this. You can graph every single one. You just gotta manipulate the equations a little bit to get y equals.
Or if you, let's say you did graph that, would the solution, would the intercepted be 4, negative 2?
Yes. Yeah. Now, in order to graph that, you'd have to mess with both equations to get y equals in both equations.
You get your, but then you gotta solve it.
Not really. I mean, you solved it by, you still have to put it in the calculator. But really, you can't do that for every single one. Alright, you guys want to try one on your own substitution?
Sure. Since we love this.
Now, number 7. Try this for a second. Now, what's the problem with number 7 with substitution?
There isn't a
You have
within
to get y by itself.
It doesn't give me x equals or y equals. So you need to pick one equation and then get x equals or y equals from it.
You don't put those together, you just pick one of them.
You're thinking elimination. Now don't actually, just try this for a second. See what happens.
Don't graph it. Now why does it have that bracket on the left side?
That just tells you it's a system of equations, so those two equations go together.
Okay.
You're on 8 now?
Well, I'm just comparing 7 to 8. What's happening with 7? If you try to solve for x or y, what happens?
We end up with fractions.
You end up with fractions. Did you guys end up with fractions?
Yeah.
Do we want fractions? No. So what do we want to do there?
Change it to those.
Don't do what they say. Substitution.
Elimination.
You want to do elimination instead there. If substitution is giving you fractions, switch to elimination. Okay?
How does
You
one?
should never, ever, ever have to do substitution with fractions. So if I can't get x or y by itself, now I don't care what the directions say. Are they spying on you? Do they know what you're doing? We don't think so, right? Okay, the only way they can force you to do one thing is to graph it. So, if they say substitution but elimination would be easier,
exactly do you do elimination?
Well, we'll talk about elimination in a minute. So we're gonna say number 7, you wanna do it by elimination. We'll come back to that. Number 8 is a much better problem for substitution, better candidate for substitution.
Yeah, 'cause you can divide evenly.
Because
It's a y by itself.
the first equation, it would be easy for me to get the y by itself. Or my other option would be the second equation, it would be easier for me to get the x by itself. Now either one of those is okay. It's just your personal preference there. But that would be a much better, if you guys wanna practice substitution, go ahead and practice on number 8. Cause that would be much easier than number 7. Now I would rather get the x by itself in the second one.
How are you gonna get the x by itself?
It really doesn't matter. Cause the y is, yeah, you can get the x by itself. It really doesn't matter.
Hmm? Oh, I get it.
Alright, so I'm out of space here. You guys work on your problem. Practice. If you need to refer to mine up here, you can refer to that.
Who knows? How in this process would we see if there's both equations are the same?
Your x's, your x's or your y's would go away at this point and you end up with just numbers.
Okay.
It's when there's something funny going on is when all your variables go away. You get a bunch of stuffers. Okay, so if I finish mine here. One six. And x equals 3. Okay, so that was a more or less easy problem because we didn't have any fractions. You should not be needing to do substitution with fractions unless you just want to. Mhm. You just start those right now. So there's your minus 24 and minus 20. Check your numbers here. I don't think 126 is right, and then you get minus 24 minus 1 should be minus 45 on the other side. Alright, so there's really very few problems we would try to do by substitution. If you guys want to see a problem with substitution where something funny happens, try to do substitution on number 5.
I got a fraction in number 8.
Yeah, I got fraction
That's
number
not,
8 too.
yeah.
No, not have fraction answers on number 8. Should be one of your answers. Okay, if you're done with number 8 and you want to see a substitution problem where something funny happens, look at number 5. Try substitution on number 5. You got negative 125. No, look at this. You got negative 24y and negative y over this side here. Negative 24 and negative 1 combined to negative 25. You got negative 25y here. Okay, we were divided by negative 25. And that's what we're going to do. So you should get rid of that. Some of the problems do have fractions. Negative 125 and then you divide by negative 25, it's just not. Dividing two numbers.
What happens on 5 is you lose your variable.
So and that's how you know something, whether it's substitution or elimination. If you lose all your variables, it's going to be
All real numbers.
something funny. So let's look at number 5. If I wanted to do substitution, the easiest thing for me to do would be to solve the second equation for x. Okay, the one we without a coefficient is generally, or with a coefficient of 1 or negative 1 is generally the one you want to solve. Okay, so if I try to solve the second equation for x, I need to subtract 3.5y from both sides. So I get x equals 1 minus 3.5y. Okay, then I'm going to plug that into my other equation in place of x. So instead of 2x, I have 2 times 1 minus 3.5y plus 7y equals 2. Okay, now if I distribute by 2, I get 2 minus 3.5 times 2 is 7y plus 7y equals 2. Now what happens is my minus 7y by 7y cancel each other out, and I end up with 2 equals 2. Okay, if you subtract the 2 from both sides, you will get 0 equals 0. Now which case is it when I get 0 equals 0?
The overlapping one?
Yes, the overlapping equations, the same equation. Basically, one equation is just a constant multiple of the other. So if I took my first equation and I divided it by 2, I would get the second one. So that would be infinitely many solutions. What does it mean graphically? The two lines are the same. Okay, now I said we